called product rule and quotient rule. Okay? So what we're going to do is product rule. You can go from two things multiplied to separate them by addition, or two things divided to separate them by subtraction. So we're going to evaluate the following. They have to have the same base, and they have to have plus or minus ones in front. Okay? Same base, plus or minus ones in front. So this one has a 1, this one has a 1, so that's good. They both have plus ones, that's good. They both have base 2s, that's good. You need those restrictions. They have to have 1s or minus ones in front, and base 2s. So we're going to get log base 2, and anything with a plus 1 in front stays in the numerator and gets multiplied. So I have a plus 1 in front, 16 is going to go in the numerator. I have a plus 1 in front, 8 is going to go in the numerator, and then I'm going to multiply them. What's 16 times 8? Did anyone figure out, sorry? 100 and something. You guys are whisper answering. 128. All right, we want to get the answer to that. So we're going to go, remember, either log 128 divided by log 2 if you use that type of calculator, or if you have the ones with the log button, you're going to go math, arrow up, and take the log base. Everyone's trying it out. You have to do it on your calculator. And I'm getting 7. So this is the same as this, because I can put it together, but try this if you want to as well. Type this into your calculator plain as day like it is. Log base 2 of 16. So what is log base 2 of 16? This is 4. That's an eraser. This is 4 plus log base 2 of 8 is 3. What's 4 plus 3? 7. Same answers, right? Try this one out. Type these into your calculator, get an answer. Type that into your calculator, get an answer. So when we put log base 3 of 27 into our calculator, we get 3. Log base 3 of 3, you get 1, and you get an answer of 4. When you put log base 3 of, what is 27 times 3? 81. Log base 3 of 81, you would get 4 as well. Okay. So it shows that you get the same answer whether you add those two or you multiply them, correct? So it is a work, it does work. So let's talk about the subtraction ones. Go. Subtraction and divide. Give her. I want to explain to you what your calculator is doing when you're typing that log in, because I don't need my calculator in order to answer these. Because I know what the calculator is doing. When your calculator, when you type in log base 2 of 16, it's giving you an answer of 4. The reason why that is what it's doing every time you type log in, everyone listening, is it's saying 2 to what power gets me 16. So 2 to what power gets me 16? 4. 2 to what power gets me 8? 3. So that's why it's going 4 minus 3 equals 1. So that's what your calculator is doing every single time. Okay? 16 divided by 8 is 2, so this is log base 2 of 2. So it's saying no. It's freezing. Awesome. Saying 2 to what power gets me 2, which is 1. Same answer. So, everyone paying attention. If it has a plus 1 in front, it goes in the numerator. A minus 1 in front, it goes in the denominator, because it would be division. That's what we did. Remember, if they subtracted, you divided them. If you added them, you multiplied them. Another way to think about it is, if they have the same base, you can put them together if they have plus or minus 1s in front. So I'm going to go log base 2. Now this one has a plus 1 in front. Everyone paying attention? So the 12 is going in the numerator. This one has a minus 1 in front. Do you see that? So the 3 is going in the denominator. So anything with a plus 1 in front goes in the numerator. Anything with a minus 1 in front goes in the denominator. And they have to have the same base in order to put them together. So now I'm going to get log base 2 of 4. Because 12 divided by 3 is 4. Yes? 2 to what power gets me 4? 2. So the answer is 2. And I didn't have to type it into my calculator at all because we could just math it. All right? So plus 1 in front goes in the numerator, minus 1 in front goes in the denominator, and they have to have the same base. So this has a plus 1 in front, base 6. This has a plus 1 in front, base 6. This has a minus 1 in front, base 6. So can I put them together? They all have plus 1s and minus 1s in front, and they're all base 6. Yes? So then using log laws, I can put them together. So I'm going to go log base 6, and I can write it as a single logarithm. Anything with a plus 1 in front goes in the numerator. Anything with a minus 1 in front goes in the denominator. So this 7 has a plus 1 in front. So where's the 7 going to go? Numerator. This 8 has a plus 1 in front. So where is it going to go? Guys, pay attention, put that somewhere else. 8's going to go in the numerator. And then whenever we have more than one thing in the numerator or denominator, we multiply them. This 2 has a minus 1 in front, so where is it going to go? Denominator. So I'm going to get log base 6 of 56 divided by 2. What's 56 divided by 2? 28. So I'm going to get log base 6 of 28, and then I'm going to stop there. Because I want a single logarithm. And I want an exact value. If I type that into my calculator, I'm going to get a delta. Okay? Yeah. All right. Example 2, I'm going to get you to put them together, but we're going to do one step together first. So I'm going to write it out. It wants you to write this as a single logarithm. So I have log base x of 10, which has a plus 1 in front. I have plus 1 log base x of 75. What do I have to do with this minus 1 in a bracket? What do you distribute? So you distribute it to here and to here. So I'm going to get minus 1 log base x of 2. Then I distribute that in, and then I'm going to get minus 1 log base x of 3. So let's remind ourselves here. Plus 1 in front, minus 1, and then base x, base x, base x, base x. So I can put them all together because they're all log base x. Right, Merritt? Yeah. I can put them all together because they're all base x, and anything with a plus 1 in front goes in the numerator, and anything with a minus 1 in front goes in the denominator. Go. So I know I can write this as log base x of a single logarithm. So 4 logarithms become one single logarithm, correct? Plus 1 in front goes to the numerator. So this is a plus 1 in front, so 10's in the numerator. Plus 1 in front, so 75's in the denominator, or sorry, in the numerator. And I multiply them. Now, guys, could I put these out of order? Could I put like the negative log x base x of 2 here? Yes. It's not like if it comes first, it goes in the numerator, and comes last, it goes in the denominator. It's plus 1's in front, numerator. Minus 1's in front, denominator. Yes? Plus 1's in front, numerator. Minus 1's in front, denominator. So that's why these two are in the numerator, because they have plus 1's in front. Then 2 goes in the denominator because there's a minus 1 in front. And 3 goes in the denominator because there's a minus 1 in front. And whenever we have more than one number, we multiply them. So I'm going to get log base x of 750 over 6. What can that reduce to? 125? So I get log base x of 125. And why do I need to be able to do this? Because, guys, I might say write this as a single logarithm in the form log base x of a, the value of a equals what as a numeric response, correct? And the value of a would be 125, yes? If you're someone who only knows how to do these because you plug them into your calculator because they're all numbers, are you going to be able to successfully answer that question? Nope. Because you're like, I can't type it in. You call me over and you're like, Miss Lepp, I can't type that into my calculator. I'm like, correct. You need to write it as a single operand. Okay, so you need to use the ruler. Yeah? Okay. You guys try this one out. Go. I'll give you 1 minute. Plus 1 in front, hint, plus 1 in front, minus 1 in front, base 2, base 2, base 2. We can put them together. Try it out. So, we have log base 2. Anything with a plus 1 in front goes in the numerator. Anything with a minus 1 in front goes in the denominator. Then we got to use exponent laws. Okay. Plus 1 in front, so the x goes in the numerator. Plus 1 in front, so the 2x goes in the numerator. Then I multiply them. Minus 1 in front, x squared in the denominator. What happens in the numerator when I multiply an x times an x? What do I get? X squared, because you multiply exponents, yeah? So I'm going to get equals log base 2. 2x times 2x is 2x squared over an x squared. And then the x squareds can cancel. So I'm left with log base 2 of 2. You could type that into your calculator. Or 2 to what power is 2? 1. Or, if you have the older calculators, you're set up well for this. Log base 2 of 2, if you have to type it in, you're going to have to go log 2 divided by log 2, which is 1. So actually, the older calculators and forcing you to do it this way helps you out in a lot of questions. So that's also 1, which is D. Okay, flip over. Okay. Most people are really good at putting logs together, but they forget that when I have things multiplied, I can pull them apart. First off, because they forget that. Second off, they don't realize that these are two things multiplied. So I will always go in and put multiplication dots to help myself out. So I'm going to put a multiplication dot here, 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 in between these. Do you see that? So remember, we can go from single logarithms to 1, but we can also go from 1 logarithm to expanded out logarithms, right? Most people are really good at putting them together, but they forget they can pull them back apart. Well, I know the answer to log A, it is 6. I know the answer to log B, it is 3. I know the answer to log C, it is 2. So if I can get things into log A, log B, log C, I can put those numbers in for those. Yeah? Okay? Determine the values of that. So that's log A times B. Is there a log A times B answer up there? No. Is there a single log A and then a single log B answer? Yeah, so I need to get these into singles. So I can go from multiplication out to addition. So this is going to equal, because they're both in the numerator, right? So I'm going to get log A plus log B. What base are these that I don't have bases? They're base 10. Could I put a base 10 here and a base 10 on all of these if that makes it easier for me? Yep. I could put base 10s on everything. Yeah? So now that I have them singly, what is the answer to log base 10 of A? 6. Plus, what is the answer to log base 10 of B? 3. So I get 6 plus 3, which is 9. What happens when I have a division? I have something in the numerator and something in the denominator. The thing in the numerator is going to get a plus 1 in front. The thing in the denominator is going to get a minus 1 in front. So this is going to turn to plus 1 log base 10 of A, if I wanted to put the base 10. And then because B is in the denominator, I'm going to get minus 1 log base 10 of B. So I'm going to end up with log base 10 of A, which is 6, minus log base 10 of b, which is 3, and now I end up with the answer of 3. You guys try C and D. So for C, they're all multiplied in the numerator, correct? Because there is no denominator. So they're all going to be added to each other. So we're going to get plus 1 log base 10 of A plus 1 log base 10 of B plus 1 log base 10 of C. So I'm going to get 6 plus 3 plus 2, which equals 11. D, you have a B times C in the denominator. So both of those are going to be what? Subtracted, negative 1s. Yeah. So we're going to get plus 1 log base 10 of A. Do I need the base 10s here? No, some people just do better with them. Minus log base 10 of B, and then C is also in the denominator, so minus log base 10 of C. So I'm going to end up with 6 minus 3 minus 2, which is 1. So we took a single logarithm and we expanded them out to numerous logarithms, yes? What are we going to do in number 2? Single logarithm from numerous logarithms, yes? So make them one logarithm, then evaluate. So one logarithm, then get an answer. Evaluate means answer. So base 4 plus 1 plus 1. So we're going to get equals. Make sure you have left side equal signs because you have this equals the next thing, right? They should all equal each other. So it equals log base 4 of 8 times 2, because they're both going to be in the numerator. So we get log base 4 of 16. And then log base 4 of 16 is 2. The next one, log base 5 screams, put me together. When they have the same base, they should scream, put me together. I need to be 1. You know what I mean? And then plus 1, minus 1. So I'm going to get log base 5. In the numerator, it's going to be 100 because there's a plus 1 in front. In the denominator, it's going to be a 4 because there's a minus 1 in front. And so I get log base 5 of 25. And log base 5 of 25 is 2. Do you see how I'm not doing these as separate logarithms and putting math together? I want it as a single log. Yep.
Can I go for example?
Yeah. So we're going to get log base 6. This has a plus 1 in front, minus 1 in front. So I'm going to get 8 in the numerator, 4 in the numerator. When I have more than one thing, I multiply them. And a 6 in the denominator. So I'm going to get log base 6 of 32 over 6. Which can reduce, or we can just type it in at that point, doesn't really matter. So it'd be log base 6 of 16 over 4, 16 over 3 is what I meant. 32 divided by 6, which is, I said nearest 10th were necessary, 93. If I wanted it in exact values, you'd go log base 6 of 16 over 3. Like you'd reduce it and just write it like that. That's an exact value. So if I ask for an exact value and you round it, you lose marks, correct? Because exact value is not a rounded decimal. That's not an exact value. So if I ask for the nearest hundredth, this would be your answer. If I ask for exact value, that's your answer. Do you see the difference? Okay. These don't scream put me together as much as when I put the base 10s on them. I find that means that screams a little more put me together. So I find that when I don't give you base 10s, people don't realize they can put them together. So we get log base 10. So there's a plus 1 in front, so 2 is in the numerator. Plus 1 in front, so 10's in the numerator. 1/5 goes in the denominator because there's a minus 1. And so I get log base 10. When I put this into my calculator, it's 20 divided by 1/5. Which is 20 times 5, which is actually 100, which is 2. These are base 10s as well. Plus 1 in front in the first one, so I'm going to get log base 10. This is a plus 1 in front, so 25 is in my numerator. This is a minus 1 in front, so a half's in my denominator. Minus 1 in front, so 5 is in my denominator. I'm going to multiply them. So I'm going to get log base 10 of 25 divided by 5 halves, which is 25 times 2/5, which is going to be 50 divided by 5, which is 10. So I'm going to get log base 10 of 10, which equals 1. And then these are all plus 1s. So they're all in the numerator. What if they were all minus 1s? They would all go in the denominator, but what would be in the numerator? A 1. Yeah, you have to have a 1. Good answer. So we get log base 10 of 3 times 4 times a half times a 6, which is actually 12 over 12. So it's log base 10 of 1, which is actually 0. Because remember, your calculator is going 10 to what power is 1? And the answer would be 0. Yeah, do you have your phone on you?
No, it's fine.
Perfect. All right. So what happens if I don't have plus or minus 1s in front? That's a problem. If I have a number in front, I have to somehow get a 1 in front. Because I can't have like 2 log base 3 of x, 4 log base 3 of x, whatever it may be. Okay? I need to have plus or minus 1s. So that's where the power rule comes in. The power rule of logs is I can take the exponent on a log and I can drop it in front, or I can take what's in front and I can move it up to the exponent. The power rule. So, example 4 says, write the following in the form log base b of m to the n. So, do you see how there's a plus 1 sitting in front of the log? That's the form it wants. It wants a plus 1 in front. Currently, I have a 2 in front. What can I do with that 2 based off the power rule? Bring it up to the exponent. You're correct. So this can equal log base 3 of x squared. Now, where would that be helpful? That would be helpful in having a whole lot of logs with the same base, but having numbers in front. I wouldn't be able to put them together as a single log until I took that number in front and raised it up as the exponent and put plus or minus 1s in front. So this one has a minus 1 in front. I could also raise that up. Log base a of 2 to the negative 1, which is the same as log base a of 1/2. If you don't believe me, type 2 to the negative 1 in your calculator. I'll go. 2 to the negative 1. You get 0.5. What's 0.5 the same as? 1/2. And if you don't know that, you could go math, enter, enter, and it'll turn it to a half for you. All right. This one we're going to bring up. So we're going to get log. Now, a lot of people, guys, watch yourself. When it doesn't have a base, a lot of you try and slot that x into the base or something like that. Do you see how it's easy to maybe now go x of 1/2? I get this all the time. This is wrong, just so you know. The x is beside the log. Do you see that? And the half is this. So if I don't have a base, I'll often put a base 10 to help myself out to not be able to slot that x in there. X to the half. And then here the 4 joins the exponent of the 2. So I'm going to get log base 6 of 2 to the 4, which equals log base 6 of 16. Example 5 we're going to do together. It says determine the value of 3 log base 2 of p minus 3 log base 2 of q. When they have the same base, which these both are base 2, It should scream in your head, put me together, if they have the same base. Like a little voice in your head should say, put these together, when it's base 2. And then if I can get something in the form p divided by q, I can replace that with the number 8. That's what it's telling me. Okay? So let's look at the actual question. 3 log base 2 of p minus 3 log base 2 of q. Am I allowed to have minus ones in front? Am I allowed to have minus ones in front? Did we have minus ones in front on the whole entire other page previous to this? Yeah. I'm allowed to have plus ones in front and minus ones in front. So do I have to move the negative sign with it and make it a weird fraction? No, I can just move the number. So I can't currently put these together because they have 3's in front. That minus sign is all fine and dandy, correct? It's the 3 that's a problem. I need to have a plus 1 in front or a minus 1 in front. So I can take this 3, move it up to the exponent, take this 3 and move it up to the exponent, but leave the minus sign. Do you see that? You can take the minus sign, but it's often way more work, and 30-2 does not make you do that. So I'm going to go equals log base 2 of p cubed, in brackets, minus log base 2 of q cubed, in brackets. See what I did there? I just moved that coefficient up in the exponent. I can do that on a log laws. And we have the 3 log laws on your formula sheet here. They're laws of logarithms. They give all 3 of them right there. Okay? Now they're both base 2, and they have plus 1's in front and minus 1 in front. So am I allowed to put them together now? Because the rule is same base, 1's in front. Minus or plus is fine. So now I can put them together as a single logarithm. So I get log base 2. The p cubed goes in the numerator because it has a plus 1 in front of the log. Right? The q cubed goes in the denominator because it has a minus 1 in front. I need p divided by q. If I have p divided by q, I can put in an 8. I have p cubed divided by q cubed. What could I do to get that to just be a p over q? What do they both have in common? The 3. So I can take the 3 out. I can't cube root or anything because I'm not solving. There's no equal to anything. I just said an expression here, so I can't cube root. But I can take the cube out. I can go p divided by q and put it to the 3. All to the 3. Because I could take the 3 and I could distribute it in as well, or I could take it out. Yes? Now do I have a p divided by cube somewhere? P divided by q? Yeah, in that bracket. And what does p divided by q equal? 8. Does it not? P divided by q equals 8. So can I replace this with an 8? This little piece right here? Yeah. So I can get log base 2 of 8 cubed. Which should be 27. No, 9. I don't know. No. Yeah. Oh my gosh, let's just be erasing. The 3 can drop in front. This would be 3. 3 times 3 is 9. The answer should be 9. You guys try example 6A, B, C, go. You either do this and then raise the power of 3, or you put the 3 in with the 8. What I like doing is dropping the 3 back in front. So I go 3 times log base 2 of 8. And then I know this is 3 times 3. So I don't have my calculator at all. Okay. Let's look at this one, example 6. So, base 2, 1 in front, 1 in front. What does that scream? Put me together in a really creepy, weird voice. So, we get log base 2 of p with a plus 1 in front, minus 1 in front, log base 2 of q. And so we get log base 2. We can put them together, plus 1 in front, minus 1 in front, base 2, base 2. So when they're the same base on a test, that literally has to hit you in the head and be like, put these ones together. Same base, put these together. When you're like, when I said everyone's good at the idea of this, but when you see something, you need to know what to do, correct? So when you see the same base, your brain has to immediately go, I must put these together. If they have plus 1s in front. If they don't have plus or minus 1s in front, I need to move that number up as the exponent, then put them together. So we're going to get log base 2 of p divided by q. And over here, p divided by q is 64. So I'm going to get log base 2 of 64. If you want to put this in, have an extra bracket. Log base 2 of 64, which is what? Because 2 to the power of 6 is 64. Okay, flipping over. Base 3, it screams, put me together. Oh wait, I can't put them together currently because what's in front of them? 4s. And what do I need in front? 1s. So I'm going to get log base 3 of a to the 4 plus log base 3 of b to the 4. Now they have plus 1s in front, so I can multiply. So I get log base 3 of a to the 4, b to the 4, which is log base 3 of a, b to the 4, which gets me log base 3, 81 to the 4. I can drop the 4 in front. So I get 4 log base 3 of 81, which is 4 times 4. If you leave it like this, you have to put that extra bracket, because that 4 needs to join that 81 in the bracket with the log. If you don't put that extra bracket, it's going to do log 83 divided by log 4 and raise that to the power of 4, which is not what you want it to do. Okay, these ones have 5s. I can divide this over q over r equals 5. You could have done it differently, but I like doing it this way. So I'm going to get 5 log base 5 of q minus 5 log base 5 of r. Raise this to the 5. Raise this to the 5. I get log base 5, q to the 5 over r to the 5. Take the 5 out, I get log base 5 of q over r to the 5 inside its own brackets. So I get log base 5 of 5 to the 5. If you want, you can drop that in front. So you get 5 log base 5 of 5, which is 5 times 1, which is 5. You put it in all at once, you need to make sure you have that extra set of brackets around the 5 to the 5. Okay. This one is a single logarithm. Do you see that? Log base 3 of 4. This one I want the sum of 2 logarithms. What's sum mean? Addition. How do I add? You need to have multiplication in order to add. So the sum of 2 logarithms, if I have log base 3 of 24, that won't work out into summing something. But if I split this into a multiplication of some sort, then I can separate it by addition, yes? So there's many options I can have for 24. Pick 2. Twelve and 2? Sure. 12 times 2. So then I can separate that as log base 3 of 12 plus log base 3 of 2. Do you see what I'm saying when I say the sum of 2 logarithms? Yeah. Yeah, just take your phone. What about the difference of two logarithms? Difference is the answer to what? Subtraction. So I'm going to have two numbers that do what in order to have them subtract? Divide. So what two numbers divide to give me 24? 48 and 2? Yeah. 48 divided by 2. So I'm going to get log base 3 of 48 minus log base 3 of 2. Just about. Okay. Example 8. I want you to try and write this as a single logarithm and these. Go. Try. A and B first. We'll do the A and B so that you can make sure you can do your turns. So base A screams put me together. However, they don't have ones in front. So I have to raise this one to a half and this one to a third. All right. So we're going to get log base A. Guess what 16 to the half is? Ooh. It's 4. 16 to the power of a half is the square root of 16. If you don't know it, that's okay. Your calculator will tell it to you. So go 16 to the power of a half, and you get 4. Because it's not 16 times 1/2, correct? 16 to the power of a half. Minus log base A, 8 to the third is the cube root of 8, which is 2. Now do we have plus or minus ones in front? Yes, and base A, so we can put them together. So we're going to get log base A. 4 goes in the numerator because there's a plus 1 in front. 2 goes in the denominator because there's a minus 1. And I get log base A of 2. The next one, I have a plus, this is base 10, base 10, base 10, plus 1 in front, 5. Okay, I have to bring it up here as an exponent. And then minus 1 in front. Okay, so we're in a position where we have all base 10s, and we have 1s and minus 1s in front. So now can I put them together? Yes. So it's going to equal log base 10. Do I need to write the base 10? No. I'm going to because often you guys will put something there if I don't put a base 10 in it, so like a little placeholder so you can't put numbers into it. And also it screams more put me together. So plus 1 in front, A goes in the numerator. Minus 1 in front, e to the 5 goes in the denominator. Minus 1 in front, a squared goes in the denominator. Now I have 1a in the numerator and 2 a's in the denominator. So what can I do? Cancel. So the numerator cancels off into a /1. And this cancels off one of those. So you still have a 1 in that numerator. So you're going to get log base 10 of 1 over a e to the 5. They often write them in alphabetical order. If you put e to the 5a, you would not be wrong. So do you see what we have to do there? If we have the same variable on the top and the bottom, we're going to have to cancel. Okay? Your job is to do these 6. Go.